Good evening, students. Today I am going to derive Poissons and Laplace equation, which I am going to derive from Gauss law of differential form. Now, for this, we need to consider the medium. We know del dot d bar is equal to del dot d bar is equal to rho, which is differential form of Gauss law. In order to derive the Poissons and Laplace equation, we need to consider differential form of Gauss law for a medium that has to be isotropic, linear, isotropic material medium. This is the consideration we need to consider for the medium in which we are going to derive for Poissons and Laplace equation. Now, the differential form of Gauss law is del dot d bar is equal to rho v, which is equation 1. This can be also be called as divergence of electric flux density is equal to volume charge density. We know d bar is equal to epsilon e bar. This is equation 2. Now substitute equation 2 in equation 1 is del dot d bar, which is equal to del dot epsilon e bar, which is equal to rho v. This is equation 3. We know that I'm going to use one more relation, which is the relationship between electric field intensity and electric potential. That is equation 4. Substitute equation 4 in equation 3 is del dot epsilon minus del v is equal to rho v, which is equation 5. Now, epsilon, I'm going to take it on the right hand side. That is minus del v, which is equal to rho v by epsilon. This is equation 6. Equation 6 can also be rearranged as del dot minus del v. Here, the minus sign on the left hand side, I'm going to take it on the right hand side, which is minus rho v by epsilon. This is equation 7. This is for inhomogeneous medium. Inhomogeneous medium. This is for inhomogeneous medium. Now, for homogeneous medium, equation 7 is modified as del square v is equal to minus rho v by epsilon. Here it is not epsilon naught. This will be epsilon only. Right. Now this is the equation 8, which is Poisson's equation. This is for homogeneous medium. Now, for Laplace equation, in equation 8, we need to keep rho v is equal to 0. Then rho square, equation 8 becomes del square v is equal to 0, which is Laplace equation. Now, What are the various laws we have considered here in order to derive the Poisson's and Laplace equation? First of all, we need to consider that the medium is linear isotropic material medium. And the first law we need to consider is differential Gauss law. And the second one is the relationship between electric flux density and electric field intensity. And the third one is the relationship between electric field intensity and electric potential. These are the laws I have used in order to derive the Poisson's and Laplace equation. Thank you, students. Thank you very much.